So I've been an architect for 20 years. I've worked on some of the world's tallest buildings. I know the way that we're building today is not sustainable. When people think about carbon emissions, they think about air conditioning and they think about cars, but what people don't realize is that just the materials in your house contain so much like embodied carbon. So Marsha is short for Mars Habitat, and so it's a home on Mars. And we started working on this with NASA. NASA approached us with this challenge of how do you build on Mars? We can't ship materials to Mars. It's too expensive to launch like construction materials and construction equipment to space. So the whole concept behind Marsha is to send small robots in advance of human explorers and harvest the materials that you find on the Martian surface to then 3D print this house. In Mars, the challenge is there's very little atmosphere on the outside of the habitat. It's very thin, so all the air inside Marsha wants to expand outwards. And so the unique shape of Marsha, and some people describe it as an egg, some people call it like a beehive, that's really the most structurally optimized form to contain the air, this bubble of Earth, and preventing it from expanding and pushing out on the structure. Once they accepted our design, then we had to go out and build a prototype. We have to sort of recreate to some degree the situation we would find on Mars. So we weren't allowed to build any of Marsha in advance. We had to put all of our 3D printing equipment on a truck and go out to Illinois and 3D print the prototype, what was actually one of the world's largest 3D printed structures in 30 hours. I think the most intriguing part of our technology and Marsha's design is that it uses biopolymer as its material. So what the biopolymer is, it's a kind of plastic which is made from corn or sugarcane or beets. It's made into a plastic, and we combine the plastic with basalt fiber. Okay, and basalt is a material that you find on Mars, you find it on the moon, and you also find a lot of it on Earth. The closer that we get to developing the technology to print on Mars, so the closer that we can get to, say, going out to a piece of land, collecting rocks and dirt and using a minimal amount of plastic and being able to build a building, that's also going to be transformative on Earth, because you don't have to make energy-intensive concrete, you don't have to make steel. There will be nothing more sustainable than going to a piece of land and just building with the materials that you find there.